Imagine a planet so black it absorbs nearly all light, darker than charcoal, darker than any known material in space. It orbits its star like a phantom, almost invisible to the eye, defying every rule we've known about planetary reflectivity. And that's just one of dozens. Our universe isn't merely vast, it's bizarre, hostile, and at times downright terrifying. Beyond the boundaries of our solar system, astronomers are uncovering worlds that shouldn't even exist. Planets that burn hotter than stars, planets made of diamond planets, with ring systems so massive they block out starlight for weeks. Some spin backwards, others glow magenta. There's even one losing its atmosphere at a rate of thousands of tons per second, leaving behind a comet-like tail of vaporized hydrogen. These are not speculative fantasies. They are scientifically confirmed exoplanets, each more haunting than the last, each challenging our assumptions about what a planet can be. So the real question isn't just what is out there, it's how are these planets even real? And what do their alien physics tell us about the ultimate fate of Earth and our place in the universe? Today we're diving into the most terrifying planets ever discovered, bodies so extreme, so improbable they've forced astrophysicists to rewrite the textbooks. From gas giants with the density of styrofoam to rocky mega-Earths that shouldn't be able to hold together, every one of these celestial outliers poses a deeper, more disturbing question. What else is waiting in the dark just beyond our reach? You've heard of Jupiter, Saturn, Mars, but you've never seen planets like these. And perhaps you were never meant to. Our journey begins 560 light-years away with Kepler 10c, a planet that broke the rules before we even understood them. It weighs 17 times more than Earth, and unlike other massive planets, it isn't made of gas. It's made of rock. That makes no sense. According to standard models, such a rocky body should have collapsed under its own weight, or accumulated a vast envelope of hydrogen. But Kepler 10c exists. It's been dubbed a mega-Earth, a category of planet that defies our understanding of planetary formation. Theories were rewritten overnight. Next, plunge into the darkness of TRES-2b, a gas giant orbiting 750 light-years away that reflects less than 1% of the light it receives. That makes it darker than coal, darker than acrylic paint. Scientists suspect its black shroud comes from vaporized sodium-potassium, or titanium oxide. But even that doesn't fully explain its eerie lack of reflectivity. It's as if TRES-2b absorbs reality itself. Now move closer, just 57 light-years to GJ504b, a planet that glows a deep magenta hue. 4 times larger than Jupiter, and far from its sun, its vibrant coloration may come from its relative youth, only 160 million years old, and atmospheric conditions we barely understand. But don't be fooled by the color. Its temperatures, chemistry, and orbital dynamics make it utterly inhospitable to life as we know it. And then we arrive at J1407b, known informally as the Lord of the Rings. Why? Because its ring system is 200 times the size of Saturn's. With 30 rings spanning tens of millions of kilometers, it's a planetary object, cloaked in a halo of colossal mystery. If Earth were orbiting inside that ring system, we'd experience weeks of darkness with every revolution. What kind of star system could sustain such an object? What kind of physics allows it to persist? As these discoveries stack up, one thing becomes clear: our concept of what's normal in the cosmos is laughably narrow. These are no longer isolated anomalies. They're signs of a universe more alien than we ever dared imagine. Not far behind in cosmic terror is Gliese 436b, a Neptune-sized world, just 33 light-years from Earth. Unlike most gas giants, it bleeds atmosphere in real time. Because it orbits a dim red star at a suicidal distance of only 4.3 million kilometers, Gliese 436b is scorched and stripped with every revolution. Astronomers have observed it, leaving behind a vast comet-like tail of hydrogen, stretching thousands of kilometers, created by the loss of up to 1,000 tons of gas per second. It's essentially a planet caught mid-disintegration, dying in slow motion before our telescopes. And yet, it remains intact, for now. Well, because its host star is weaker than our Sun by just enough to delay the inevitable. Had the star been even slightly more massive, Gliese 436b would have long since been obliterated. But it clings on burning, bleeding, orbiting. Another ticking clock. Now shift your gaze 1/400 light-years out to WASP 12b, a planet that completes a full orbit around its star in just over 24 hours. That speed causes it to stretch into an egg shape due to the enormous tidal forces pulling on it from all directions. These same forces also heat its atmosphere to 2,500 degrees hot enough to melt titanium. And here's the horror story: WASP 12b is being actively devoured. Every second, its host star siphons away bits of its atmosphere. It's been estimated the planet has less than 10 million years left before it's entirely consumed, its atoms absorbed into the star's fiery corona. What we're witnessing is a slow-motion planetary execution. Next up is HD 106906b. At first glance, it looks like a frozen gas giant 300 light-years from Earth and 11 times the mass of Jupiter. But here's the twist: it's orbiting its star at 650 times the Earth-Sun distance. That's 97 billion kilometers. In that icy outer realm, it should never have formed. And yet, there it is. How did it get there? Some theories suggest a massive gravitational slingshot, perhaps caused by another passing star or even a hidden planet-sized body in the system. Others think it's a failed brown dwarf that got trapped in orbit, but one thing is certain: it doesn't belong. Its orbit and mass challenge every accepted model of how star systems evolve. Then there's Gliese 581c, once hailed as the most Earth-like exoplanet ever found. Discovered in 2007 and only 20 light-years away, it resides in the so-called habitable zone. For years, scientists dreamed it might have liquid water, perhaps even life. But deeper analysis painted a different picture. Gliese 581c is likely tidally locked, meaning one side constantly faces its star, while the other lies in perpetual darkness. Over time, this creates temperature extremes and a volatile atmosphere more like Venus than Earth. What once seemed like a potential Eden may, in fact, be a carbon-drenched hellscape. These discoveries force us to confront uncomfortable truths. Our solar system, with its relative calm and stability, isn't the cosmic norm. It's the exception. And these extreme planets may be a preview of our own future chaos, collapse, and extinction, written into the structure of the universe itself. Now the story escalates with HD 188753b, a planet that by all accounts should not exist. Orbiting within a triple star system, just 149 light-years from Earth, it completes its lap around its primary star in a mere 3.3 days. The problem: traditional models say such planets can't form in this kind of environment. The gravitational chaos from 3 stars would disrupt any early planetary disk before it could coalesce into a stable body. And yet, HD 188753b is there. One hypothesis is that it formed elsewhere, then was gravitationally captured after a near miss with another star system, a violent cosmic adoption, if you will. Whatever the case, its presence challenges everything we thought we knew about planetary nurseries and orbital stability. But if that seems strange, wait until you meet GJ 1214b, a planet made mostly of water, but not the kind we understand. Located 42 light-years from Earth, GJ 1214b has a low-density and an enormous volume of water locked under extreme pressure. But with surface temperatures exceeding 200 degrees Celsius, it doesn't host lakes or oceans like Earth. Instead, scientists believe it contains exotic forms of water, superheated high-pressure phases never seen in our world. Think of hot ice or superfluid water states, where liquid and solid blur reacting to temperature and pressure in alien ways. If you stepped onto its surface, if you even could, you'd be swimming through chemistry that breaks Earth's laws. Then there's 55 Cancri E, often called the Diamond Planet. Found in a binary star system, just 40 light-years away, it orbits its sun in 18 hours. So close its surface sizzles at 2,700 degrees Celsius. Based on the carbon-oxygen ratios, detected researchers theorize that beneath its blazing crust lies a thick layer of graphite, and deeper still a mantle rich in diamonds, billions of carats. But this isn't a cosmic jewelry store, it's a pressure cooker of carbon-based death. Any surface probe would be vaporized in seconds. And still, it rotates relentlessly, a furnace of condensed wealth we may never reach. Now enter WASP 17b, a bloated gas giant with the lowest density of any known planet. Twice as wide as Jupiter, but half its mass. It's so light it could float in water. Even more disturbing is its motion. It orbits its star, backwards in retrograde. This indicates a violent origin, perhaps a near collision with another massive body early in its life. And because its size is so out of sync with its mass, some physicists question whether it's truly stable at all. What if it's in the process of shedding its outer layers? What if it's slowly unraveling one orbit at a time? That brings us to HAT P7b, another massive exoplanet in a backward orbit. But what makes it unforgettable is its weather. Yes, weather. This planet has aluminum-rich clouds composed of ruby and sapphire dust, blown by supersonic winds across its atmosphere. Imagine storms of gemstone vapor sweeping across a sky of metallic hydrogen. With its host star 50 times more luminous than our Sun, HAT P7b isn't just hot, it's violently radiant. Its atmospheric patterns are so extreme, they've been used as analogs for understanding atmospheric dynamics on young gas giants and even failed stars. These examples aren't just curiosities, they are warnings. The universe doesn't care about our sense of order. It doesn't care if a planet orbits backwards or evaporates in front of us or defies formation rules entirely. These are the frontiers of astrophysics, and perhaps the early signs that we still vastly underestimate how hostile and alien our universe truly is. And then we arrive at one of the most chilling case studies, 2-mass J2126-8140. This planet is not just far from Earth, it's far from everything. It orbits a small red dwarf star at a staggering distance, nearly 7,000 times farther than Earth orbits the Sun. That's over 1 trillion kilometers away. For decades, scientists didn't even realize it was orbiting anything at all. They thought it was a free-floating rogue. Its orbital period, an unfathomable 900,000 years. That means this planet hasn't even completed a full orbit since modern humans evolved. It blurs the line between planet and brown dwarf, a body so massive it teeters on the edge of becoming a failed star. If there's a loneliest planet in the galaxy, this might be it. But perhaps the most sobering discovery of all is Kepler 438b. Roughly the size of Earth and sitting in the habitable zone of its star, it once seemed like the holy grail, an Earth twin that could potentially host life. It orbits a dim red dwarf every 35 days and maintains surface temperatures between 3 to 10 degrees Celsius. But the dream collapses quickly. Its host star, while cooler than our Sun, is far more unstable. It bombards Kepler 438b with intense solar flares and radiation enough to strip away any potential atmosphere. Worse yet, the star is aging into a red giant, and will expand to engulf the planet within 200 million years. That might sound like a long time, but in cosmic terms, it's a blink. This is a vision of Earth's future. Billions of years from now, as our sun swells into a red giant, it will consume Mercury, Venus, and yes, Earth. And just like Kepler 438b, our blue planet will vanish into the plasma of an aging star. In a universe filled with planets on fire, frozen in shadows, bleeding their atmospheres, or spinning backwards, Earth stands as a precarious anomaly. Temperate, stable, alive, but perhaps not forever. Every new discovery beyond our solar system reminds us that life as we know it is an exception, not a rule. The cosmos isn't built for comfort, it's built for extremes. Some planets shimmer like gemstones, others are consumed by their suns, and some drift in lonely isolation for nearly 1 million years per orbit. These are not science fiction tales. They are real, documented, and expanding every year. So what do these alien worlds truly mean for us? Are they warnings of how rare Earth really is, or previews of what's to come? We stand at the edge of cosmic knowledge, peering into the darkness, mapping the impossible. But as our instruments grow sharper and our discoveries more terrifying, one question remains. What kind of planet is still waiting to be found, hidden just beyond the reach of our telescopes, defying even the extremes we've come to accept?